Hello everyone, my name is Andrei Kostin and I'm the CEO and co-founder of Binare.io, a cybersecurity spin-off from University of Jyväskylä in central Finland. And I'm also an assistant professor and senior lecturer at University of Jyväskylä. And it is my great pleasure to be here today presenting at Barcelona Cybersecurity Congress. Unfortunately, due to flight cancellations and delays and a lot of mix-up of traveling, I am not able to be there, even though originally planned to be. But still, it's my pleasure to be remotely with you, with the entire audience, and I hope this presentation plays well at our slot of the Lazarus project. As Tarek and Adriana have already presented before me the whole motivation for the project and some background about it from the motivation perspective and from the business perspective, I will try to be covering a little bit more technical aspects of the project and some of its implementation and demos. So I'll start from here. Most likely, Adriana and Tarek already explained that we aim to develop a platform which is called the Lazarus platform, which is a quite complex modular architecture that aims to provide DevSecOps functionality to a broad spectrum of projects and enterprises, and in particular SMEs. So the main aim of the platform is to offer the enterprises or the organizations and SMEs using the Lazarus platform is to offer them closer to NIS and GDPR compliance, in the sense that it helps discover vulnerabilities as early as possible and have a more automated, more closed loop feedback system type of resolution fixing for cybersecurity issues. Also, it aims to provide information intelligence sharing to CERTs and CCERTs and ISACs in order to facilitate the vulnerability disclosure processes, patching, coordination, and so on. Also, another aim of the Lazarus project in the big scheme of things is to provide resiliency and self-healing, meaning that for certain types of projects, the technology allows to detect vulnerabilities and also to suggest patches that make certain types of projects and code less vulnerable or completely invulnerable to detected vulnerabilities. Moreover, the whole idea of being a modular and flexible platform is to build it around microservice architectures and provide it as part of a bigger tool set, or that will allow integration with GitHub or GitLab type of DevSecOps and CI/CD solutions, so that the whole platform can be plug and play into an existing build and test and deploy pipeline. Also, and finally, the automated vulnerability discovery, whether these vulnerabilities are in the code, in terms of source code vulnerabilities, or these vulnerabilities are in the form of, let's say, configuration or misconfigurations, forgotten or hard-coded passwords or secrets buried down into the software, whether it's own software or whether it's software that's coming from third parties as part of a software supply chain activities. So these kind of vulnerabilities are also important to be discovered as early as possible and as automatically as possible. We aim to apply Lazarus during the project and at the end of the project on several pilot use cases, where in the consortium we have 4 companies that besides developing the technology itself, they also serve as pilot use cases where the Lazarus platform will be applied and tested and improved in those corresponding partners' infrastructure. So we have marketing technology partner, we have a partner providing enterprise software, so strengthening the enterprise solutions. Then we also have the media and publishing or content management system, so that the content management systems can be more secure and provide less vulnerabilities, while everyone is aware for example, the problems that are posed by vulnerabilities when WordPress is being affected. There are many sites or many organizations impacted by such vulnerabilities, so we want to lower that kind of impact. Also IoT technology and data analytics for IoT. So the idea is to use Lazarus to bolster the IoT device security and analytics, and also to enhance those types of solutions that actually are used to discover vulnerabilities in IoT, firmware, and embedded devices. So a little bit of motivation. We have enough motivations for cybersecurity and why we need DevSecOps and why we need automation and good tooling and good flexible and modular platforms. But the most recent case of XZ utility backdoor that was a critical one, 10.0, a fully exploitable one, very sophisticated as well. So it showcases that how persistent adversaries can be. They can infiltrate a particular project or infrastructure years prior to the actual attack. So the idea is that the attacks happen at the intrusion point is not true anymore. So the attack itself or the exploit can happen years after. So the lifespan of observation for cybersecurity should be much longer than just a couple of milliseconds or a couple of days that we usually store in the logs. And it should also comprise not just normal network or computing activities, but also all other, let's say, agile development, testing, deployment, committing, reviewing code type of activities that are part of a bigger pipeline, a bigger technological picture. Yes, we've covered that an adversary can be patient and can wait quite long to implant a very sophisticated, very technically capable backdoor, and that is very flexible and very hard to detect. And it was more like a lucky occurrence that it was detected in a way, the persistence of certain engineer that had a good eye for anomaly that has slipped. That anomaly has slipped under the radar of any anomaly detection tools in terms of performance and impact on SSH and the PostgreSQL testing that was performed by that engineer. Then the human factor of that humans know better, that the reviews will always be covered by humans, and that is a bulletproof solution, also turned to be wrong. That we can see that even very, very seasoned professionals with gaining trust from the third parties, maybe their vigilance goes a little bit down, maybe they are overloaded by other types of issues, ensuring the maintenance and continuity of the projects. So it is hard to spot these types of sophisticated backdoors or vulnerabilities being there. And also it is very interesting that all these pipelines that existed in all these Linux distributions and all these utility systems and automatic build and test and security tests of the code and of the deliverables and the build files themselves, proving that all these pipelines, they are connected to existing cybersecurity tools. Nevertheless, they all missed the whole this entire backdoor implant, and almost some of them actually missed it up to the deployment to the bleeding edge branches. So it means that even the existing tools can be easily fooled or relatively easily fooled. And again, the detection was thanks to a very keen eye of a human engineer, and it was strict. The detection was strict by some anomaly on the performance side, not even on the security side. So it once again underpins the existence, the inefficiencies that exist in all existing DevSecOps and SAST and DAST tools. And yeah, we know that we are far from perfect, but this example shows that even the best solutions in the world cannot easily detect. Of course, now they can detect it because it's known, but they couldn't detect it when it was an actual 0 day. So that underlines the challenges that we are facing, especially as developers and open source community and so on. So what we are trying to also do here is basically we develop a Lazarus platform that is, as I mentioned, it has multiple modules. A lot of these models are normally auxiliary models, such as the reporting and monitoring and web interfacing and user authentication and authorization. But there are a lot of other models that we are developing specifically for this project, such as patch creation, sandboxing of certain deployments, so that we can do penetration testing or fuzzing. All this interconnected with monitoring nodes for anomaly detection and self-healing. And all the data that we process is taken from repositories with source code or binary artifacts, is being processed by the models that we are developing, and I'll cover the models in the next slides. And then all the detections and information that we detect and report would go back to the repositories either as a bug report or as an issue for further tracking, or if it's a vulnerability or exploit or exploitation, that will also go as part of information sharing, so that it can be distributed in a more or less uniform machine readable manner to certs, CSerts, and ISACs, so that all these organizations and response teams can proactively detect and mitigate and look for possible backward or forward detection of exploitation and threat actors. So at the technology infrastructure level, we have the Lazarus components that has an API gateway where we have multiple services being integrated. All these are RESTful, REST-based microservice architecture type of services, Dockerized, pretty flexible. All these services implement one or multiple types of activity or scans or detections or patching or self-healing or reporting. They all integrate with message broker that efficiently manages the requests back and forth between the services, the users, the clients on the either user side through the browser or command line clients, as I'll demonstrate in the videos. And then also coordinates the request and status with the API gateway, so that the orchestrator and UI module can display the information or update it to the user into the browser or to other relevant orchestrated modules. And of course, it also features a centralized storage where all the results, temporary results, intermediate results, and final results and reports and discoveries are being stored and then subsequently can be retrieved for reporting or information sharing purposes. So we are at the alpha version right now. We still have a beta version milestone ahead about September. And then we also have a final version release in September 2025. So there's still quite some milestone, but for the alpha version, we have the user interface, the sequence scanning, the SBOM scanning, source code vulnerability detection and patching, and SQL injection vulnerability detection. I will show some demos, some video demos that are easier to show what's going on there. But a quick glance, this is a snapshot of how the interface looks like. Again, it can be replaced by any other convenient user interface of the by the end user who use the Lazarus platform in the end, because it's based on the APIs and you can build rich interfaces on top of that. The secret scanning modules uses AI trained models to detect the various types of secrets, whether it's API tokens or standard credential or other types of secrets embedded into the source code or configuration files or binary code. Again, this is AI-based implementation that has its foundation on a peer-reviewed academic paper that has been accepted to a highly reputable conference. And again, there's a lot of trust in that this model works quite well. It's not just a glorified regular expression that normally is simple enough and good enough to catch some of the secrets, but not good enough to catch all the varieties or cumbersome or unexpected type of credentials or tokens being embedded here and there. So it scans for different types of credentials and tokens. Again, you can see on the slides, but I'll show you in the video in a few seconds. So these are some examples of test files that we put in a test repository, and then we give it to the Lazarus platform, and it will detect it and detect all the sample credentials and tokens, and then return it as part of an API response in a machine-readable JSON format. Then we have a software bill of material, which is very important and is part of the software supply chain security, as we witnessed with XA utils backdoor. And basically, this is scanning for various third-party components, their versions, and then matching them to NVD CVE databases or similar, and then provides any accumulated list of vulnerabilities that are associated with corresponding third parties and software components that are part of a given project that is scanned by Lazarus. Well, it returns a configurable number of parameters, including the vulnerability ID or CVE ID, and the description, and also the base score for each vulnerability, and then any other additional summary information related to all the vulnerabilities, like the total number of elements and so on. Then we have source code vulnerability detection and patching. So the first step is usually by this module is to detect the vulnerability. Currently it supports the JavaScript source code language, but new languages are added as we progress through the project. And it uses different transformer architecture baseline solutions that are being fine-tuned to the project and to the language. And then once the vulnerability is detected, it also generates most likely secure patch for the given vulnerability. Of course, those patches need to be manually reviewed by a human, or also be tested in a more dynamic environment to ensure that patch is correct, and also it doesn't break other functionality and also fixes the vulnerability. Nevertheless, the generation of the patch itself is fully automatic based on the AI and machine learning models that are part of the same bigger vulnerability detection and patching AI models. So this is the diagram in general, how this architecture, internal architecture of the code vulnerability detection and patching module works. So there's the model, deep learning model, that is about a couple gigabytes in size at this point, and most likely it will go further. Maybe more different modules will be added. We have a lot of benefits and properties that this model brings. I'll leave it to your screen to grasp how many positive things it can bring. But again, the whole idea is to have it as automatic and as accurate as possible. Then we have the SQL injection vulnerability detection module that will dynamically test the endpoints for SQL injection and try to detect them and report them. So it's more part of a dynamic and sandbox type of testing. So in conclusion, the idea of Lazarus, you can see above. I'll reiterate this in a couple of minutes. I just want to share a couple of videos with you showcasing the platform. So okay, so here I started a video, screen save video of our Lazarus alpha version server, where we have a Lazarus CLI command line interface that interacts with the API endpoints, and we have a project named Lazarus Test Alpha Project, for example, and we want to get some of these parameters, for example, including the configuration schema. So it's a schema that describes what kind of configuration we can set to this kind of project. So generally, at this moment, we allow the users of Lazarus platform to get to configure the repository URL where the source code, configuration, or binary build artifacts are being stored, and then provide all the URL and access credentials to this repository. This credential can be in form of SSH keys or API tokens or username and password combinations, so it's quite flexible how the Lazarus can access these repositories. And then once the repository can be accessed, a particular target branch, usually it's the main one, but it can be another development or testing branch that could be a target of a test by Lazarus. And then it also tells which of these parameters are required. So target branch, you can see it's an optional parameter. So if it's not specified, then a default value such as main will be taken. And then we go further. And you will see that we will issue the next CLI command, which is basically we give a particular, we do a post config, meaning that we set for this particular project, we set a particular config that you can see here, template 100 test config.json. So we created a JSON, which is conformant to this schema and contains the actual value for these parameters, and we will set those parameters for this project, for Lazarus Test Alpha project, using this post config action, and we will issue this by Lazarus command line interface. Okay, so the configuration has been processed successfully, so all the required parameters have been supplied and the values are correct and JSON format is complete. And the next one, we can double check that our configuration has been saved. So we issue a get config parameter for the same project, and as you will see here, we have supplied a target repository url.com/test and some git dummy git access credential, and we didn't specify any target branch, so it's we'll assume some default. Okay, so the next command, you see that we perform a get request schema. So now we can perform different actions or requests to the Lazarus platform to be executed on this Lazarus Test Alpha project. And subsequently, these requests will be executed on the repository or set of files associated with this project. So we request the schema. The schema contains various properties that needs to be supplied as part of the request. Examples of these requests include, for example, the modules that we want to invoke, for example, secret scanning, and so on and so forth. You can see that, and then we actually issue a request. Here is a bit, one second, it moved a little bit. Okay, so you can see that we post a request, and we give it a request ID, and then it will be submitted. And this request will basically trigger the orchestrator and API gateway to interact, and then invoke the corresponding service modules that are running in order to perform a particular type of analysis or scanning or secret scanning or vulnerability detection or vulnerability patching. So the status is submitted, and then you can see that you can pull it from time to time as part of continuous integration. So you do a get request, and then it will give you all the details if that request is completed. So all the modules have been executed on the repository or on relevant files of the repository, then it will return the results. So you can see here it's a mix of linting that is happening on certain files, and the linting will tell the textual output and some other information. So in this case, the line is too long, so linting module says, well, it's better to have a bit different code organization. So this code organization can lead to better maintenance and readability of the code, as well as less, let's say, vulnerabilities that are prone to misinterpreting the code because of too short or too long lines or things like that. So you can see once all the modules are executed on a particular big repository, there could be a lot of output in a single request, and all that output is being summarized, and it will be displayed in the dashboard so that appropriate action can be taken. Okay, so this is one example because time is running out, so I don't want to spend too much time. I will show you now the UI that we have right now. Again, the UI usually is not the main thing because we want, at least at early versions, because we need to implement the backend functionality as well as possible, and then the UI will just use and display all the information in an eye candy manner. But nevertheless, I'll show you the UI that we have right now. Okay, so here's an example of UI. It's running on a local development host, so it has a pretty standard login screen. It's very basic right now, and then once a user logs in, the user can select various services. And once the services have been selected and configured, and the repository URL have been provided to the UI, basically it will invoke pretty much similar backend APIs as I have been showing you through the terminal and command line interface, and we can start running it. And once the processing has been completed, we can monitor a particular scan, and at some point when the results are ready, then the UI will display it accordingly. So you see that we are monitoring it, and once the results are ready, it's available for display or download, so we can download the report and see it later. At the moment, we don't have any particular very fancy reporting and eye candy capabilities, but you can imagine that we can use those very same machine readable JSONs to present it in a very nice dashboard manner with all the graphs and bars and donuts and all the detailed information split across pagination screens and so on, which will we will do in the beta version that is upcoming. Okay, so in conclusion, the idea of Lazarus is to automate DevSecOps transition. We also aim and demonstrate that we leverage AI for security with quite advanced AI models for different scenarios. We also aim to do dynamic detection of various types of vulnerabilities and attacks, like SQL injection in a dynamic testing environment, also dynamic detection of various network-based attacks. One of the main things is we want to give high flexibility in customizing your pipeline so that your DevSecOps processes and approaches are effective and efficient, and you can select whatever modules that you need for your particular repository or project. You don't need all the modules in the world to be effective and efficient. And yes, please stay tuned and follow us for the latest updates and new versions as we release. Follow us on website, on the LinkedIn and Twitter. And once again, thank you to Adriana, Tarek, and all the organizers for hosting our session. Thank you so much, and until next time. Thank you.